Good morning, everyone, and welcome to the NASA International Space Ups Challenge of Mountain View. This year we're virtual, and we're so glad you're here. We tried to make a really compelling programming for you so you enjoy it. But just a few words. Hi, my name is Martina. I'm your annual local lead here in Mountain View, where we usually host this location at NASA Ames Research Center. But because of the shutdown, we're now moving virtually, but we're still the biggest location in the US. Next slide, please. But let's talk a bit more about SpaceApps today. So, what is SpaceApps? SpaceApps is the largest annual global hackathon, and it's addressing real-world problems in Earth and in space. And what does that mean? Well, that means that NASA and other collaboration agencies that are collaborating on the most pressing problems are creating new challenges for you to solve every single day. And they're targeting annually these novel challenges for the most pressing issues for Earth and for space. And you can contribute. Your ideas are so valuable, and we're so grateful that you're going to be hacking with us today. This hackathon is held each October for a course of 2 days, so today and tomorrow. And we connect scientists to NASA Open Data, and we connect you to the same NASA Open Data that you can utilize in your solutions. The hackathon is for everyone. At SpaceUps, there's always room for one more. So you can be from any walk of professions, and we are accepting all ages, but we're so grateful we have a really cool competitive talent pool here in the Bay Area. These hackathons are in over 400 locations worldwide, and they can be both virtual or in person, just like our events, sometimes even hybrid, like we always do that in Mountain View, so we have more accessibility. But these challenges are created by NASA experts, and participants pick out a challenge and join a team. We have 19 this year. You can always create your own, but the 19 challenges are super fun to solve and hack from. But yeah, you can pick any challenge to tackle that you wish. You can be as experienced or as inexperienced as one gets in the novelty of the field when you're new, or if you're a seasoned expert, we also have slots for you to be our mentor or judge. And the space agency's experts judge these projects, especially for the global nomination. And we do have some awards, and we're going to talk about them later. Next slide, please. But the NASA Space Up Challenge by the Number is really the biggest annual hackathon. It's run by the NASA's Office of Chief Information Officer, and it's a part of the NASA Science Mission Directorate and of the Open Government Initiative. And SpaceX is managed by the Earth Science Division as well. And the winners actually go to the NASA headquarters in Washington, D.C., if you were to win globally. So, how this goes is usually we have these local locations where we're all competing. And then from the local locations, we provide global nominees based on our judges and the winners that they pick. And then those global nominees go for global judging, and the winners of that global ceremony are invited to headquarters. So that's really exciting. We have a lot of cool roles in our Space Ups volunteering community. We have you as participants. We have our agency partners like NASA and the other space agencies that are supporting this hackathon globally. We have a lot of subject matter experts. We have local leads like me. We have navigators that can help you navigate the hackathon. We have mentors and judges in the local locations. We have a lot of partners and collaborators, and obviously our winning teams that are moving forward in the global. Just to give you a perspective, if we can move to the next slide, we have a worldwide participation. You can sort of like see your map. I think last year we surpassed 100,000 registrations, and we had over 400 territories and countries hosting this hackathon. So it's really cool to hack at the same time with a lot of other coders and hackers and innovators and curious people across the globe. Next slide, please. So yeah, we already covered the NASA Space Agency partners, but you can see we have a lot. We have JAXA, we have the Canadian Space Agency, we have ESA, we have the Turkish Space Agency, and a lot of them are coming together to support this hackathon locally. Next slide, please. Our subject matter experts are coming from NASA. So we have really talented people that are creating these hackathons for you to be more easy to navigate, but also guide you, sorry. From left to right, we have Argiro, Daniel, and Shobhana, and they're one of the experts that have aided this hackathon. Next slide, please. The local leads are the people organizing this in your local community. So what we do is we apply for a location, we get access and permission based on our experience, and then we lead the location. We make this hackathon happen in the local community where we are. So we have a year-long training for this. It's really exciting to kind of like connect with everybody who's passionate about creating community. And I'm super fortunate to be in Space Up since 2014. I myself joined as a participant in 2014, and I didn't think we're gonna win because we were one of the youngest teams. We won with first place. We almost went home before the winners were announced, but I'm thankful we submitted a solution. And that participation led me onwards towards my space career. I'm now a human spaceflight expert at Blue Abyss, and I run a non-for-profit called International Space Alliance that aids this hackathon. But it was quite a journey for me. I went from participant to mentor to judge to an organizing team member to a local lead. So it's been almost a decade of my involvement in this hackathon. So that's quite cool. Next slide, please. Your navigators are the people who will help you navigate this challenge, but we also have our local navigators and our volunteers in the Slack and Discord. So hopefully you've joined our Slack and Discord channel that's available for you. We've communicated that. If we haven't, email us at nasaspaceups@gmail.com or email us at martina@internationalspacealliance.com, russell@internationalspacealliance.com, or bobby@internationalspacealliance.com so we can forward you more of that programming in case we've missed you and you're just registering right now. But we have these navigators to help you with a lot of things of how the hackathon is run, what are the rules and regulations, how to pick up the challenge, how to register and submit a solution, or how to form a team. Next slide, please. Our collaborators this year, we have quite a lovely support. We have global collaborators, but we also have local collaborators. So our location is partnering with NASA Ames Research Center, our local host and collaborator, Microsoft, Microsoft Azure, Google, Elastic, Archer Aviation, LifeShip, Mova Globes, Blue Origin Club for the Future, Minerva University, Carnegie Mellon University, Red Rock Coffee, Red Bull, Aerospace and Defense Review, Topgolf, and many more that we can announce towards the winner celebration. So we're trying our best this year to host this hackathon virtually, but also hopefully host the winner celebration at the NASA Ames facility or a similar venue as soon as we open with the government. So we'll, update you for that. But for now, we can move on to the winning teams. Next slide, please. So our winning teams this year, we're hoping to get at least 4 global nominations. How this hackathon works is it's scalable. From 1 to 10 submitted projects, so make sure you submit your project. From 1 to 10 submitted projects, we have to get a chance of 1 global nomination. From 10 to 12 to 20, we have a chance to nominate a second global nominee. From 20 to 30, we can get the chance to have a third global nominee. So it scales like that. So the more projects you submit, you help yourself and your other teammates to grow and hopefully win a nomination for the global victory. Your submission for the project can be anything. It can be a pitch deck. I believe you have a limit up to 7 slides. It can be a 30-second video. It can be both. You can choose as easy or as hard as you want to make this. So you help yourself submit something, because sometimes even good ideas win. We are striving to have the best technical challenges as well, but your idea is so valuable in your community. We try to have an elaborate overview of good ideas and platform them. So submit as much as you can to help your fellow teammates and yourself to hopefully win this location. But the winning teams also are having the local prizes. For example, winners can get MOBA Globes in the first place or live ship kits as well. We have a lot of cool swag for you guys and some surprises that we're gonna announce hopefully due to tomorrow. But from winning locally, you also hopefully get to win globally. You're competing with a lot of cool locations, but I'm certain that the Bay Area has exceptional talent. And from what I've seen in the registrations, first, we're the biggest location, and second, we have exceptional individuals creating. So I cannot wait to see your solutions. Next slide, please. These are some of the photos of how the hackathon kind of like happens. It happens all across the world, from venues to cafes to universities, you name it. The beauty of our location is that we're one of the rare locations, the only one in the world now that's collaborating with a NASA facility. I mean, we're hosting it at the NASA Ames Research Center. So we have that unique value proposition when it comes to interacting with the civil servants as experts, mentors, and judges, and hopefully you'll get to see them on the winner's ceremony. Next slide, please. This is our today's agenda. This is your day one of the welcoming of the NASA Space of Challenge 2025. I really want to wish you the bestest of luck, and I truly want to encourage you to hack and give your best to solve a problem, because so much innovation has happened in the Bay Area. We have so much acceleration happening in the Bay Area. This area is so unique because you can grow and scale immensely if you have a good idea, and we can help you there. But soon, in about 15 minutes, 15 to 20 minutes, you will hear an opening keynote from Dr. Andrew Aldrin from Aldrin Family Foundation. He is the son of Buzz Aldrin, and I'll tell you more about him later. Then at 3 p.m. today, we have a closing keynote from somebody who was a mentor at NASA SpaceX, Rama Afulo. He's now the CEO of Satellite. And then we're gonna leave you to hack, just because we've learned throughout the years that when we have heavy programming and when we brought so many people in the ballroom to talk and give lectures and have panels, participants tended to move out of the ballroom to find quiet spaces for hacking. So we've learned by practice that leaving you space for hacking is super important. So we're gonna leave you a lot of space to create the best possible scenarios, and we're gonna be there for you on email, on Slack, and on Discord. So if you haven't joined us, please feel free to join. But that's the programming for today. And now let's move to the QR codes. So these are our QR codes, and if you haven't, please send them to the teammates that might not have gotten this information. We're gonna keep onboarding them as the day goes. We still have, I think, some bandwidth for registrations. We actually encourage registrations. So if your team is not up to 6 people, perhaps welcome your friends in this hackathon to have a glimpse of this experience and a glimpse of this adventure. Just because we want to remain the biggest location in the US, and your help is really valuable for that. But these are our QR codes. If you can just either make a screenshot out of this, or perhaps send it to the group chat or wherever, you're gonna find our Zoom webinar for the day one. You're gonna find the Zoom webinar for day two. Those are different Zooms. And you're gonna find the participant Slack and also the team formation Slack. Hopefully throughout the day or by day two, we'll update you more with these interactive QR codes, because we need your feedback and whatnot. So you're gonna see these coming in your communications. But please, if you haven't, make sure you register. Registering is so important, just because from that website registration, we get the list, and that's how we can update you and send you emails. So it's quite important. Also, hopefully today with us, if you can go to the next slide, please. We have Archer Aviation, one of our partners, and we have Zohia Mian. He's the VP Software and DevSecOps and Product of Cybersecurity at Archer. So he's currently the Vice President of Software. at Archer Aviation. He received his Bachelor's of Science at the Middle East Technical University with a degree in aerospace engineering and a minor in production engineering and mechanical engineering. He then went to receive the master's and PhD at Georgia Institute of Technology. His PhD is in aerospace engineering, autonomous systems, and his master's is also in aerospace engineering, system design, and optimization. Prior to Archer, he was the vice president of engineering, autonomy, and AI ML at Aptiv. So if Zohaib is here, perhaps we can invite him to share a few words and encourage our participants.
Hey, good morning, everyone. Thanks for the intro, Martina. That was more than what I was expecting, but it's great to be here with everyone. As Martina said, I'm Zohaib Mian. I lead software over at Archer. And on behalf of the entire Archer team, thank you for having us. We are really proud to be one of the sponsors of this year's NASA International Space Apps Challenge. And to be frank, like this was no brainer for us to back this challenge, right? The spirit of this challenge is to use passion and creativity and tech to solve huge problems, which is exactly what we are all about at Archer. We have brought in the best minds around the world, in from different areas, aerospace, automotive, tech, to challenge a significant challenges of our own. And one of those is urban mobility that people may be familiar with, right? We're creating EV tools to enable us to go from one place to another in very, very short amount of time compared to what it would take. It's not only about saving time, but it's about getting that time back and using that time for things like this, exactly where we're bringing together within this NASA Space Apps Challenge the most brilliant people from around the world to actually look at and solve some of the hardest problems that we may have around the world, right? I think it's this belief that we have together, Martina, that we can tackle the impossible. That's what this is all about. This is what I
Mhm.
see when I look at all the participants, and I think this is what we're going to do for the whole for the entire weekend here, and that could be anything from trying to send rovers to Mars, solve traffic problems in LA, or even address some of the more harder challenges that people have in their minds. So I think I'm really excited for the next 48 hours. I think it's going to be go big, be creative, don't be afraid to fail type of opportunity for all of us that are here. And we at Archer are super excited to be part of this weekend and can't wait to see what comes out of it. So thank you.
We're so grateful for Archer, and if you can stay a bit more, I just want I want to ask you a few more questions, if that's okay with you.
Oh,
For
absolutely. Yeah.
example, one of my questions is, how did you get inspired to get into space exploration? For me, it was early access to it, and an early kind of like experiencing a hackathon and solving a hard problem that drove me there because we solve these difficult problems in space exploration, and those are the most difficult questions we ponder upon. So what was like your first initial inspiration to drive you to the field?
Yeah. Look, aerospace was something that inspired me from the very beginning. That's why, as you can see, my whole entire career has been based on it. It is a one of the most difficult set of problems to go after, and like you just mentioned, it's very similar. It is what we consider to be a final frontier. Um, the fact is that when you are trying to solve problems for whether getting to space, staying in space, going between planets, those problems have also huge application on Earth as well, right? So if you can solve those problems, you can actually leverage what knowledge we gain from there into aspects that we need over here down on Earth. There are many examples that we have seen throughout history: material advancements, propulsion advancements, thermal resistive materials, and so on. So it's just the love of going to space and flying. Honestly, I can't put it more simply than that.
I absolutely share the sentiment. And I would love to know personally, and I'm sure the participants would love to know, how did Archer come to life? What was the initial inspiration? What drove you to create it as a team? If you can tell me more about Archer, just so we make it more known to our participants about the mission and the goals and the objectives, anything you can share.
Yeah, absolutely. So I alluded to that a little bit in the opening statement. The idea behind Archer was uh, at core, let's look at some of the biggest, hardest transportation problems that we have seen, right? If we can um, reduce the amount of time it takes you to go from one place to another, which could be a brutal 60-minute commute, into something that will take only a few minutes,
Mm-hmm.
and we can do this using sustainable methods, that is collectively a huge impact to the environment, huge impact to people. And like I was mentioning, it's getting the time back that we spend. If you think about it, how much time people spend commuting through their day, and what you can do with that time, it would be a huge thing, right? So at core, it was very, very simple, right? We want to make what is considered impossible in terms of travel, and turn that into a possibility. And um, and we are now well on our way to do that. If you are following, yeah, I'm sure you are, but if others have been following as well, on our Progress on Midnight airplane, which is designed to actually do exactly that. And we're also going to be flying in Salinas this weekend at the air show. But
Oh,
if
cool.
anyone's interested, yeah.
We'll definitely stay tuned for that. And thank you so much, Zahia, for your incredible time and contributions, personally and through Archer at this hackathon. We're so grateful to have you guys, and we'll highlight you more in the remaining time of our hackathon. Stay tuned. Next, we are gonna talk a bit more about our sponsors, and we'll go more in depth with the rest of the supporting sponsorships that we have. If we can go to the next slide, please. Again, thanks to Archer Aviation. And next we have a Microsoft. With Microsoft this year, we're currently partnering with Microsoft Azure. And we're going to tell you more about it. We've even recorded a cool video of how we can solve SpaceOps problems with Microsoft Azure in a really simple way that we're going to share throughout our programming today and tomorrow. I'm sure if you look throughout our social media, you'll find some of that, but we have a lot of surprises for you coming up from Microsoft. And next slide, please. One of our main sponsors is also Elastic, and I've seen so many people from Elastic in our chat, in our rooms here, and also they're going to be your mentors, and we're going to also tell you more about Elastic in our programming a bit later, just because now I have to also announce our keynote, Dr. Andrew Aldrin. I'm sure that we're pressed with time, so I'm gonna go back to Elastic soon, but yeah. Oh, sorry. I think we have JD from Elastic here that might be speaking. I did not realize he might be ready for that.
Hello, NASA Space Apps. Let me share my screen. Are we
Hey,
pressed for
JD.
time or hello, Martina. How's it going?
How are you doing? Hi. I'm so thankful that Elastic is sponsoring us. I thought you might be coming later, but it's so cool to have you in the opening ceremony. So welcome. Hi.
Yes. Yeah, we're so happy to be involved today and see all the amazing demos. I'm sure everybody will build. Props to the team for the quick pivot to a virtual event. I know the government shutdown kind of threw a wrench into everything.
We're doing our best, and we're so thankful that everybody's adapting, and we've been actually growing just because we do have some type of a limit of how much NASA Ames can hold in the venue. So
Mhm.
this gave us the ability to expand more, but with that, we also have to answer to more challenges for onboarding everyone and having everyone on board. But thank you so much for being flexible. I would love if you tell our participants a bit more about yourself, as well as a bit more about Elastic and how you guys are supporting us.
Yeah, sure. So, are we pressed for time? How much time do you think I have?
We're gonna be flexible. That's okay. Go on.
Okay, great. Yeah, so hello, NASA Space Apps. I'm JD Armada. I'm a developer advocate at Elastic. Again, super excited to be involved with the event today. You might have heard of us as Elasticsearch, and we started off as a search engine and evolved into more of a full data and search AI platform. And what I kind of want to show off today is how you can take a NASA data set and something that you might be or probably will use in your project and turn it into something searchable, queryable, and even conversational using Elastic. So basically use us to get your data in, query it, let your agent talk to it, and use Elasticsearch to find the most relevant data. So if you allow me to share my screen.
Absolutely. I'm sure my team can have that happen. There we are. Hello.
Okay, perfect. So, quick rundown of what Elastic is. Elastic is a distributed search and analytics database, super fast at indexing and querying both structured and unstructured data. So, a way you can think of it is it stores JSON documents instead of rows and tables. Every field is going to be searchable and aggregatable, and includes a whole host of different search strategies from your basic lexical search to geospatial search, which I'm sure you guys will be interested in, all the way to vector search. So mix of a database, a search engine, and an analytics layer. And why it's useful at this hackathon. Um, in hackathons, I know that time is kind of your enemy, and we don't have a ton of
hmm
time. And so you get these huge NASA CSVs or APIs, and the first few hours kind of just disappear, just trying to parse, clean, or query them. With Elastic Cloud, you can literally upload a CSV or your documents directly, connect to an API endpoint, and automatically infers the types, the timestamps, geo points, etc. And after that, once your data is in Elasticsearch, you can search and aggregate instantly without, having to design a schema or having to set up a separate database. And one thing that we wanted to highlight, a new feature that we have that'll be useful to the participants is this new agent builder that we have. And so Agent Builder is basically a framework to build agents built directly on top of your data. Traditionally, to build an agent means you have to put together an LLM, a vector database, separate systems for logging and tracing. That can take a lot of time to build, right? Which you don't have again in this hackathon. And Agent Builder kind of integrates all those data, tools, reasoning loop, observability directly into the Elastic Stack. And here's a little bit of the architecture diagram. So with it, you can register tools that execute queries or actions against your data. And you can also expose this through MCP. You can build custom agents where you define objectives, workflows, guardrails, etc., and expose that using A2A in the future. But you can also do everything we're about to show you with direct API calls. And it's all powered by the tools that I mentioned from Elasticsearch, which is built on top of your data. Um, so instead of building everything from scratch, you can focus purely on what you want your agents to do, and you'll have the peace of mind that its output is grounded in real data. And a little background on what pushed us to make something like Agent Builder is a problem you'll probably run into, which is the context problem, right? Everyone here has probably interacted with an LLM before and are probably going to use an LLM in some part of your project this weekend. And we all know how bad LLMs can hallucinate and drift, either when there's too much information, not enough, or the wrong information is given. So if you ask a LLM something like, what is the average reflectance for coastal areas in California? It might just guess, or worse, it'll probably just make something up, right? Because LLMs aren't really built to engineer the context around them. They don't know how to grab the right slice of data and ground their reasoning in it. And that's kind of the problem we're looking to tackle. Your agent is only going to be ever as good as the context it has. And in cases like with NASA Tech, you need agents that are reliable, and bad context means bad results, and you need a way to guarantee relevance. And Elastic has always been about relevance in search, and now with AI agents, we're giving the same capability of cutting through noise and retrieving the most relevant data at the right time. So how to get started with Agent Builder, we're going to just visit our website at elastic.co and sign up for a free trial. We do offer a free 2-week free trial, which should be plenty for this hackathon. And you actually don't need to put in any payment methods like a credit card. So it's really easy to sign up and start tinkering around. You're going to want to select the serverless deployments, get your data in there, enable Agent Builder. Then there you can register tools, build your custom agents, and expose either those with MCP or direct API calls. Just a quick note of how to get your data into Elasticsearch. So we do have a bunch of different official language clients for Python, JS. You could, use that client, get your data from an API, and programmatically get your data into your index, or you can actually just upload it straight into the UI that we have. It'll auto detect the types, geo, numeric, etc. And right when you get that data in there, it becomes instantly searchable. And just a little example of how to do that in Python, we're just installing the packages, importing our libraries and our authentication, initializing the connection with Elasticsearch. This is how we index a document, the output that you should get on how your ingestion went. And then right there, you can already perform a search. So we're naming our index and the query that we want to send through. And it should give us back our document that we ingested. So just a little bit of a demo on Agent Builder. Once you sign up for that serverless deployment, you should be greeted with a page that looks something like this. And the first thing that we're going to do is enable Agent Builder. So it's still in tech preview, so it's behind some feature flags. So we're going to go into our developer tools here, and all we need is one command into our Kibana internal settings, and we're going to change this into false or into true, and we're going to send that through. And once we see Agent Builder on the right here with the user value true, it should be enabled, and all we need to do is refresh the page, and we see a new option in our navigation here. So click that in. But before we do that, let's get some data into there. So again, you could do this programmatically, or you could just click the upload file. We're going to select some light emittance data. Where did I put that? There it is. So once you get that import, hit that import. We're going to actually click on the advanced. And one thing that you do want to pay attention here is to make sure that you have all the correct mappings. Again, Elasticsearch will already infer all these types for these fields, which is great that you don't have to do those manually. But you want to make sure for things like if you want to run aggregations or calculations on specific fields, like find the average reflectance, you're going to want to make sure that the type is a numeric type, just so Elasticsearch can actually run those calculations on them. And we can see here that it already created a geopoint field using our latitude and longitude, which is great, so you don't have to do that manually. And one thing I do see that we can improve is that with dates, it's set as the type keyword, but we actually want to have that as a type date, just so that we can query and filter based on dates. So let me quickly copy over, just so I don't take too much time. So you just want to make sure this format matches whatever's in your data set. Give it an index name, click import, and you should be ready to go. Once you get those green checks of everything has been ingested correctly, we can head over to Discover just to have a quick list view of our data. We'll expand one of the documents here. Just quickly look over our types. We see that our date is of the date type, and the fields that we want to keep numeric types are of a numeric type, so that's all good there. And so since we enabled this, we can go into this agents tab, and you can already start chatting with your data using this built-in chat. But what makes it super powerful is when we can register and manage our own tools. So we'll click into manage tools here. And again, once you start chatting with your data, you can give it a natural language query, like what is the average reflectance, and it'll generate a ESQL query from that. For those of you guys who don't know, ESQL is Elasticsearch Query Language. It lets you search, filter, and analyze data across your indices. It's sort of like SQL, but it's optimized for Elasticsearch. So again, you can use filters, joins, stats, aggregations in this one pipeline. And say that you don't want to generate an ESQL query from every prompt you do, right? This is where it gets really powerful in that it gives you a lot more control and precision over what your agents can actually do, and where it gets the data from. And that's with registering tools. So we're going to click new tool here, and we'll just quickly look over a tool that we already created. This is reflectance by wavelength. For the description, you want to give it a natural language description just so the agents can actually understand what the tool does. And inside the configuration, this is where we can put our ESQL query. So it says from our reflectance data index, where reflectance is greater than 0 and less than 1, we're going to want to create some fields for different wavelengths and then calculate the average reflectance by those ranges. And once you have that saved, again, you can expose this tool set with MCP. So you can, this is pretty much plug and play with any LLM tool that consumes MCP servers. Just copy the server URL and plug that into your config, and it should be usable. But in order to use it with the built-in chat, we're going to want to create a new agent. And, oops, sorry. Let's manage our agents. So I already created one here, and I give it an agent ID. And with creating your own custom agents, most of you guys have already done that, so you know what a system prompt is. That's basically what the custom instructions are. You basically want to give it a role and a primary function. And this is probably an area you're probably going to want to iterate over, because depending on which model you use will kind of define how much it follows the instructions, right? With smaller models, you're going to want to be super verbose in your instructions at every step. With larger models, they're usually pretty good at following instructions, and you don't have to be super explicit in your instructions. So I just basically said that you're an assistant that helps scientists and hackathon participants with our data set. Always answer questions using the most relevant tool and keep your answers concise. I'll give it a display name and a description and click save. And we can already start chatting with our data. So using those tools, I'll give it a query like, show me the average reflectance group by visible, near infrared, or shortwave infrared ranges. Send that over. All right. So not only does it give us the answers that we were looking for, the output we were looking for, but it also gave us a little bit of a visual, and you can, again, tailor that to whichever visuals that you want. And it gave us some key observations. And what's neat about using this built-in chat, it does give you automatic traces with your tool calling. So it did call the correct tool. This is the ESQL query that it ran. And this is the query that we put in our tool. So that's all good there. And yeah, so you don't have to, again, you don't have to use this built-in chat. It's pretty plug and play. And that makes it pretty powerful because it's built directly on your data and you have a lot of control on where it picks the data from. So just to recap, why use Elastic for this hackathon? Again, it's really fast. You can ingest and query your data in minutes. You can maintain relevance. You can build agents with real world context. We have the 2-week free trial, which should be great for this hackathon without having to put any payment required. And we have a ton of docs, articles with examples. And me and my colleague, Philip, will be here to help all weekend. Thank you guys so much.
That was a lovely presentation. Thank you so much, JD, for explaining this so simply and for you and Philip being here. We'll make sure you are marked adequately across our Slack and Discord as mentors so participants can reach you and join you guys. That's going to be amazing for you to have hands-on help if anyone wants to implement Elastic or utilize it in their solution. The more we have aid, the better, I feel like. Thanks once again to Elastic and the contribution for this hackathon and for the last minute virtual transition and presenting with us. If we can have the next slide, please. Okay, so now I'm going to talk to you about two things. First, let's introduce our keynote opening speaker, Dr. Andrew Aldrin. He's the president of Aldrin Family Foundation, an organization dedicated to harness the inspiration of space to ignite passion for education in students of all ages and backgrounds. They do a lot of cool things with rovers, robots, you name it. He has served in leadership roles in this organization since 2014, at the same time as I started Space Apps. And he has overseen the extension of educational programs to over 300 elementary schools and universities. Dr. Andrew Aldrin grew up in the space age, in the space race. He's the son of Buzz Aldrin. And he has an exceptional career understanding how the ecosystem developed internationally. He was also the director of the ISU Center for Space Entrepreneurship at Florida Tech, where I went to study, and I got the Aldrin Family Foundation Scholarship. And he is the Associate Professor of Engineering and Management at Florida Tech, and now he opened a recent program at Embry-Riddle University that's remote. Dr. Andrew Aldrin is exceptional. He was the president of the Moon Express, responsible for the operations of the company. Prior to that, he was the director of business development and advanced programs at ULA, or United Launch Alliance, where he oversaw development of corporate strategies, business capture, senior customer relations, and advanced program development for civil space markets. Before ULA, Dr. Aldrin headed business development and advanced programs for Boeing's NASA Systems and Launch Services business units. He has also served as resident consultant at the RAND Corporation and professional research staff member at the Institute for Defense Analysis. Sorry, Dr. Andrew Aldrin is generously recording a video for us from Australia. He is at the biggest company conference called IAF, or the International Astronautical Federation Congress. It's founded in 1951. The International Astronautical Federation is the world's leading space advocacy body, with almost 600 members in 81 countries, where I'm also a part of several subcommittees like the European Subcommittee or the Access Subcommittee, where all leading space agencies, companies, and research institutions and universities and everybody else goes to meet every year. So IAF hosts these elaborate, huge conferences from research to showcases on several layers where everybody flies there. And it's super, super, super busy. Anybody in the space sector is there right now. This year is in Sydney, next year is in Turkey. It was in Milan and in Baku and in Paris these last years. And it's like our biggest con. Like we all go there if we're in space. But he was so generous in that busy time to record a video for IAF. And when you think about IAF, and when I'm educating you for these novel things, think about people who define the Kármán line, where space kind of like starts or ends, or people who give astronaut wings. Those are the people who created or are a part of the IAF, and it has a strong legacy. But yeah. We're so thankful for Andrew Aldrin, and now my team is going to play you the video of this exceptional person who knows space inside and out and is still proactively learning and engaging. So stay tuned for Dr. Aldrin joining us virtually from Australia.
underwater training. So he had been scuba diving, but he started scuba diving a lot more. This is Andy Aldrin. I am Director of Space Programs at Embry-Riddle University. I've been a space cadet for my entire life. I mean, literally since I was 6 years old. You all enlisted in space, so to speak. You all chose to be part of space. I got drafted when I was 6 years old. My dad was training to do a spacewalk, and he pioneered underwater training. So he had been scuba diving, but he started scuba diving a lot more. And so I was going to be his dive buddy. At 6 years old, he strapped a tank onto me, and I was his dive buddy as he was thinking about spacewalks. And for the next 60 years, we talked about space. Mostly I listened because my dad talks a lot and doesn't listen all that well. But yeah, for 60 years, I've been a space cadet in one way, shape, or form, growing up with my dad, working in research institutes, working in industry. And for about the last 10 years, I'm a space educator. And it's been the most rewarding part of my life. And the thing about being an educator is it forces you to think about stuff. And I think about a lot of different things in space. And so we're going to talk about some of that stuff. You know, the thing about Apollo was it was probably the largest space startup in history, because when these guys started, you know, they were 26, 27 years old. They were just walking into an organization that didn't have any boundaries. They had a clear goal. It was an audacious goal, and they did whatever they could to make things happen. And so, you know, one of the most incredible stories about the moon to me is, so the original architecture actually looked eerily like SpaceX's architecture to go to the moon right now. Von Braun had massive rockets that were going to send massive rockets to the moon, and it wasn't going to work. And there was a guy named John Houbolt, who wasn't really that senior of a guy at Langley Research Center in Virginia. It wasn't even like, it used to be sort of really important research center back in the 20s and 30s. Wasn't all that important. So this guy wasn't a big dog engineer. He just had an idea. And his idea was, instead of sending a big rocket to the moon, what you do is actually send little stuff and something small that goes to the moon and comes back, and you actually rendezvous in lunar orbit instead of rendezvousing in Earth orbit. And that changed everything. And so he went to Von Braun. Von Braun was literally a god of space. And he went to him, pitched this idea, and Von Braun initially didn't really like it, but he came around pretty quickly. And that's an astonishing achievement, to have decisions coming up from the very bottom up to the top and it happening. That's the startup mentality. And that's what all of you are kind of growing up in. The other great entrepreneurship story I have is I started my career as a Sovietologist. I studied the Soviet Union, but I was still pretty much a space cadet. So one of the questions, one of the passions I had was, how did the Soviet Union beat the United States into space? And it was a process of entrepreneurship. You had guys at the bottom, guys, there weren't too many women involved in this in Russia at the time, who before World War II were dreaming of going into space. And then World War II came, and a lot of these people got thrown, in fact, Korolev got thrown into prisons in Siberia, and spent a lot of time in Siberia, a lot of the war in Siberia, because Stalin thought they were enemies of the people because they were smart. And they still believed in space. And after the war, they got out and they got to Germany, and they started looking at what the Germans had done. And they said, this stuff is incredible. Stalin, the Soviet leadership, didn't really care about V2s and German rockets, but these guys did. And they brought it back to Russia, and nobody would take it. They didn't want to have anything to do with spacecraft. They wanted long-range bombers and all that. But these guys managed to work together. They were sitting in 6 different ministries, and they created a space program that the leadership didn't want. And they sold it. And then all of a sudden, when they launched Sputnik, it was a great moment that they called up Sergei Khrushchev, the premier at the time. And they said, we launched something into space. Isn't that great? Khrushchev said, you know, it's really late at night. You guys are great. See you later. Bye. And then, of course, the rest of the world went nuts. And from that point on, but they built a program from the bottom up They were true entrepreneurs. Sergei Korolev was the world's first, and I'll say still the greatest space entrepreneur ever. And so, I mean, there are great stories from the history of space entrepreneurship. You weren't the first ones to do this, but you, all of you are the luckiest people and the luckiest space cadets in the world ever. Because you're going to have the opportunity to do stuff that couldn't be done. You're all going to have the opportunity at some point in your career, I think, to apply for jobs on the moon. Right? You all know that you're going to have the opportunity to fly in space. We've literally got kids in high schools building satellites. Think about that, building satellites today. And so this is the most exciting time in space ever. And you should be thankful just how fortunate you are. You should be excited too, because you all got great careers ahead of you. And I'm really, really, I'm excited for all of you. First of all, it's a great time to be in space. But not all space is great. There are parts of space that are really great. There are parts of space that aren't so great. We don't need to get in that much to some of the parts that I am not a huge fan of launch. Launch is a really tough business. But I'll tell you what I am a fan of is geospatial. When I mean geospatial, I think about the big business that you're in. Right. If you're in satellite communications, you're in SATCOM, but you're really in telecommunications, right? Because you're competing with fiber, you're competing with cellular and all that, and it's a tough competition. And satellites will lose that competition, which is one of the reasons I'm not in love with that. Why I am in love with space-based observation, space-based geospatial data is you can do things in space that you simply can't do anywhere else, and they must be done. Space will never get taken over by something else. You can't have enough drones around to do the things you need to do in space. So the data is all going to come from space. But that industry is going to change dramatically. It's going to change from, right now we've got a company that builds satellites, and they're building their satellites and they're processing the data, and then they're selling the data, and they're selling just their data, whether it's hyperspectral, which is wonderful data, RF data, panchromatic, whatever. And they're just selling their single data stream. But we've got, last count, I think I had 70 different companies that are building EO platforms, selling basically any kind of data, but they're all selling it separately to their customers. And their customers are like farmers in the Amazon. And it's literally like some astronaut is descending from Silicon Valley with an iPad trying to sell somebody a farmer data, and the farmer looks like, dude, you just came from Mars as far as I'm concerned. And so that's going to change. That business is going to resegment. And I think the biggest driver of that change is probably going to be machine language, because what's going to happen is you've got all of these different sensors, different places, different times, different resolutions, dumping data into a data processor using artificial intelligence or whatever we're going to be calling it next year to process that data and do incredible things with it. But the amazing part of it is going to be the person on the ground that understands what the customer really needs and understands what the satellite can produce and understands what you can do with artificial intelligence to generate incredibly powerful products. But that segmentation is going to have to happen, and it's going to create incredible opportunities for all of you, particularly in the area of data processing, artificial intelligence, all that kind of stuff. And so that's where I get super excited. I mean, I think that's like, it's a $50 billion a year industry for the commercial side of it. The government side of it will continue to be, I mean, we spend something between 50 and $70 billion on geospatial in the government, and it's national security. So don't forget that. That is the big dog in that industry. But I think the commercial side of it is going to be driving the technology more than anything. I don't think the National Reconnaissance Office will ever be dependent upon commercial sources for their most strategic data, the stuff that they really use to blow up things. That I don't think they'll ever get comfortable with that. But I think and that's not to say working in the national security community isn't a horrible thing. I mean, I like the Space Force. It's a really exciting organization, but it is the military, and the military I just spent 2 days in a workshop with military educators, and they're more concerned, frankly, about, figuring out their own organization. But I think there are exciting technical things happening in that industry. I'm obviously an old guy. Some of my students call me the cosmic curmudgeon. I don't really know a whole lot about AI. You guys know about AI, but I do think about where the great applications are. And I already mentioned geospatial. I think that's easy. We know that's going to be great. One of the things that I think has potential and really kind of interesting potential for reshaping the industry is AI and engineering. And the way I think about it is, I teach a course in space systems management. It's actually, we do launch systems, a bunch of different things. But in doing that, we use a lot of cost models, because cost is obviously something which is very important. And you have to use parametric models. And so when you look at cost and what drives cost for development of systems, there are two things that are important. One thing is the maturity of your design. So if you've got a design that's like generation 5 design, it's going to cost a lot less to do generation 6 than it was to do generation 1, because you've learned a lot. The other thing that's important is the experience of your team. These two things can drive down costs by more than 50%. Now, that is what AI does, right? It takes your level of knowledge from a first system to a fifth system, if you've got good data. And it takes the experience level of your team from first year to 10th, if you've got data. And so the question is, for space companies, where is that data? And the interesting bit, and I say interesting kind of in an academic sense, because it's just an interesting question to me, because I'm not working in industry. But for you all, it may be interesting more in the Chinese sense that, may you live in interesting times. Here's the thing. Startup companies don't have the data, right? BlackSky, Spire, these companies have a track record of 2 or 3, 5, 10 years at the most. But you look at the legacy companies, and so they've been building stuff for decades. They got tons of data. So they can build they're capable, they've got the data to build really good models. Whereas the startups are going to be a little disadvantaged. They don't have that data. And so what's going to happen with that? And I mean, the startups are obviously dynamic and have, I think, much more aggressive innovation. And by the way, most of the innovation is on the managerial side, willingness to take risk. I mean, the major innovation about SpaceX and reusability wasn't reusability. We knew how to do that. We just thought you had to pull apart the whole engine to do it, and they didn't. The first time I went to I only went to one heavy launch where I actually got to see the boosters before they launched. We went into saw them there. The 2 outboard boosters, they didn't clean them up. They're full of carbon. The innovation was just to say, let's do it again, see what happens. And that took a lot of guts, but that's the major innovation. And I'm sure that Tom Mueller did lots of incredible things in designing engines that are capable of that. But you remember, the RD-180 was supposed to be good for reusable. Nobody ever had the guts to launch it again. So that's the innovation. But I think what's going to happen, getting back to startup companies who have this innovative mindset, but they don't have the data. Now, you could see some really interesting industry reorganizations, because there are legacy companies that I could see getting out of the space business, particularly if a startup comes in and goes, you know what, we'll give you $100 billion for your database. I won't mention any companies, but as a shareholder in one of those companies, I'd have to look at it and go, I can take that deal. And then you may see that kind of really interesting industry reorganization in ways you never thought about AI driving the market. Yeah, so I think it's going to, aside from everything else, I just think you're going to see industry move in so many directions you hadn't even thought about. And a lot of the stuff you think about probably isn't going to happen. I've got 2 pieces of advice for you. I'm old enough that I ought to have more, but I'm going to make it 2. The first is follow your passion. If you see something that's cool that you want to do, particularly, I mean, you all have got the career space to do it. Go do something that's cool that you're passionate about. Because, I mean, space is a great place, but, and don't be afraid to move around. That's the first piece. Second piece of advice is it's the questions that are important, and ask hard questions, and don't settle for rubbish as an answer. I mean, question everything. It is a good thing, because particularly as you're growing up in an AI world, I believe firmly that it's artificial stupidity if you ask it the wrong question. It's not intelligence. And you will always be the source of intelligence for artificial intelligence. And don't forget that. The important thing is you got to know the right questions. And I think AI is going to liberate you all to do thinking rather than grinding on data or code or whatever. And that's going to be really exciting. So have fun.
That's a wrap of Andrew Aldrin's involvement. We're so grateful that he could manage to spend the time to join us all the way from Australia, from the exciting IAC, to do a more exciting thing and encourage us to hack. But we're gonna be back with a closing keynote of Rama, and we're gonna leave you to hack. But before we go, just a few reminders. So if you haven't already registered all of your teammates or friends, please invite them to sign up on the website, because the website closes by the end of the hackathon, but we want everybody to form a team and join the team formation. We have channels on Slack and on Discord for you guys to form the teams, and we're gonna send another email to properly invite you again, but you probably have this in the onboarding email if you've registered yesterday night. So we haven't updated the last 2 or 3 participants coming in perhaps now, but everything has been updated with the due diligence all the way late yesterday night. But yeah, find the Slack channels for teams and team formations on Slack and Discord. Mentors will help you there, and volunteers will also help you there. Mentors will help you solve your difficult problems. Please be mindful, we're all volunteering here to help you solve the best solutions. So try to search through the chat history in case somebody else answered a question, or be patient with mentors and volunteering team as they're allocating their free time to help you in the best way. Again, we're transitioning. Every year, the budget gets renegotiated around the end of September and the 1st of October. So we're trying to do our best virtually, and thanks for all of the sponsors coming, Archer Aviation, Elastic, Microsoft, everybody who has been a lovely keynote. We've promised you surprises, and we have surprises directly coming in and showing you the know-how or the inspiration or the story behind all of these great businesses and all of these great corporations and space agencies. So please form your teams if you haven't. You can form a team from 1 to 6 participants. Try to submit a 7-page presentation or a 30-second, 30-second video as soon as possible. You can submit something and then resubmit it again and again and again. But we want to have early submissions because, as we've mentioned, we have gradual global nominations. From 1 to 10, 1 global nominee. From 10 to 20 submissions, 2 global nominees. From 20 to 30 submissions, 3 global nominees, etc. Now we have 49 teams. If we get 50 teams, we have 5 global nominations. So invite your friends. If you have 51 teams, we have 6 global nominations. So 6 of you can compete globally. So we're 2 teams away from 5 to 6 global nominations if everybody submits something. So do your due diligence of an early submission and then kind of like re-upload it or edit it or adjust it, because that way the judges can see your gradual process. They can spend more time in your solutions, and they can spend more time looking and browsing of your early submissions so they can evaluate you better. So you're helping us as well. You can submit until tomorrow at 23:59, meaning at 11:59 p.m. You can submit, and again, please be reliant to our comms, our Discord, our Slack, our emails. If you haven't, we're gonna put up the QR codes shortly for you, and we're gonna try to stream the QR codes, and this Zoom will be hopefully active until later in the day, until 8-ish p.m. But yeah, that's all for today. We'll keep you updated as soon as we have new things to share with you. And we have a lot of surprises coming up. So come back at 3 p.m. and happy hacking.